Hi guys, let's do linked list cycle. So we're given a head, which is the head of a linked list, and they want us to determine if the linked list has a cycle in it. And they say there's a cycle in the linked list if there's some node in the list that can be reached again by continuously following the next pointer. So, okay, and then they tell us that they use this variable pos, which is used to denote the index of the node that the tail's next pointer is connected to, but it's not a parameter, and they want us to return true if there is a cycle in the linked list, otherwise return false. So let's take a look at these examples. So in example 1, we have head pointing to 3, and we return true because there is a cycle in here, as we can see, from -4 pointing back to 2. And then in example 2, we also return true because in this one, we have a cycle where 2 points back to the head at 1. Example 3, we return false because there's no cycle. So for this one, we're going to want to use a 2-pointer. So we'll have a slow pointer that moves 1 node per iteration and a fast node that moves 2 nodes per iteration. So I'll show you what I mean by using example 2 because it's a little bit more simple, so it's easier to explain without having to draw everything out. So we start both fast and slow pointer, and I'll use S for slow and F for fast. So slow and fast are both pointed at node 1 right now, right? And then after 1 iteration, then slow moves 1 and fast moves 2. So slow will point at 2, fast will move to 2 and then back to 1, so fast will be there. That's after 1 iteration. And then the next iteration, we're going to move slow 1, so then keep in mind there's an arrow pointing from 2 to 1. So we're going to move S back to 1, and then fast will move to 2 and then back to 1. So then once they meet, then we know that there's a cycle, so we can return true. And for one that doesn't have a cycle, we are basically we would reach the end of the linked list and they would not have met because fast will reach the end first and it'll just become null if that's the case, like here. So if we say if we move fast 2 iterations, that's nothing, so then they can't possibly meet, right? So let's start by defining our slow pointer, which we'll initialize to head, and our fast pointer. And then we're just going to do a while loop. So while we have not reached the end of the linked list, which is while fast is not null. And we also have to say fast.next is not null because, so if there's an odd number or something, then if we are going by 2s, then fast might be the second to last one. So let's say we have example 2, but there's no arrow pointing back to 1, right? So if we're at 1 and then we say fast.next because we're moving it by 2, then fast.next is 2 and then 2.next would be null. So we also can't move that there, you know what I mean? So we have to also check fast.next. And we don't need to check slow because slow is always going to be behind fast. So if fast is not ever null, then slow is not ever going to be null. So we should be okay. So then we just want to increment slow by 1. So slow is moving to the next node. And then we'll do the same for fast, except fast we're moving it by 2. And then we want to check if they're equal to each other. So if these are the same node, then we'll return true because we know we have a cycle, because that means that the fast node caught up to the slow node. So if slow is fast, return true. And then if we reach the end of the linked list and we did not find anywhere they're equal to each other, then we'll return false because that means there's no cycle. So okay, and then our time complexity is O of n, where n is the number of nodes in our linked list. So this is because, so we have this one while loop, which will traverse through every single node in the list. So if there's there's 2 possible cases here, right? So one case is that there's no cycle, and if there's no cycle, then we just traverse every single node 1 time, and that's it. And then we just exit, right? Because fast will reach the end, we won't find anything, and we'll just exit the loop and return false. So that's O of n because we visited every node once. And then if there is a cycle, then basically when we enter the cycle, so like let's look at example 1 here. So if fast, like we are going 2 by 2 by 2, and then once we fast and slow are both in the cycle, then there's, first of all, to get to the cycle where the cycle is, they traversed linearly to O of n as well, to get to where the cycle is, right? Because they just traversed the entire linked list once and then like one extra one to get into the cycle. So that's O of n so far. And then when we have both the slow and fast node in the cycle, then they're at most they're at most n nodes apart from each other, like in between where they need to catch up, right? So like if slow is at 2 and fast is at 0, then there always needs to be less than n nodes left for fast to be able to catch up to slow. Does that make sense? So like if there's 4 nodes in this linked list, then if fast is 0, slow is 2, then there's like, well, I guess slow is still moving along with fast, but there's currently 2 nodes in between. So like if we play this out, right, fast is 0, slow is 2, then after one more iteration, then fast is 2 and slow is 0, and then after one more iteration, then fast is -4 and slow is also -4, and they've caught up. So that's only, they've traversed like, basically fast traversed from 0 to -4, which is 4 nodes, which is the number of nodes that we have in the linked list. So it's basically traversing another O of n, which gives us O of n plus O of n, worst case, which is basically still just O of n. So that's why we have O of n, whether we have a cycle or not. And then our space complexity is O of 1. Because we don't have any data structures, we just have a slow pointer and a fast pointer. And so since we only used 2 list nodes, then we just have O of 1 space. So that's it for this problem. Thank you guys for watching. Bye.